In this tutorial, we will cover calibrating the magnification, also known as setting the scale of a particular image and thus a recipe. I'll note that we can perform this calibration in either of the first four apps here, but it is typically performed in the image processor, so that is where we will demonstrate. So let's open up an image. We'll take our example gamma prime particle image. And let's say that we had some threshold. I won't focus on a perfect segmentation here, but there we have a selection of the features. Now, if we wanted to make some measurement of those features, say we wanted to measure their diameter and also color by them, let's just quickly show that. And now, without any calibration, our measurements are made in pixels because the software does not know how big a physical pixel is, whether it's a mile or a micron, so it simply measures the size-based measurements in units of pixels. To inform it as to how large a pixel is so that it can measure in units other than pixels, sometimes images have metadata buried in them in their image tags, which you can view, that might have the pixel size. Other times you may know that factor offhand. That isn't typically the case. If you did, you can just type it in here. We work in units of microns in Mipar, so be sure to type it in microns. The most common need is to calculate what this factor is from something that has a known distance in an image. If you can put some sort of line across that object and then tell Mipar the physical size of that line in reality, it will know how many pixels that line is, it'll know what you told it, and then it'll know what the physical size of a pixel is. This known object is typically a scale bar that has been printed by the microscope, in some cases by users. Sometimes your image will have a scale bar in it that you may have cropped out or otherwise avoided in a recipe. If your image does have one, then you'll simply open that image from the Calibrate tool. If your image does not have one, you'll need another image that does have one, and be sure that that other image is taken at the same magnification with the same image size. So if this image is, say, here is 1338 by 907, make sure that the image that you're measuring, the image that you're using to calibrate that has the scale bar, is also taken at the same microscope magnification at this image and is 1338 by 907. So we have one of those images. We'll click on Calibrate, and again, if your image that you're working on has a scale bar, just open that same image that you opened in the image processor. We have a different image here that does have a scale bar, which tends to be good practice when you're working on image processing. You tend to have a library of images that are at the different mags that you work at, so that you always have a scale bar at hand, but you don't necessarily print your scale bar on every image that you acquire from the microscope. And what we can do here is just take our zoom tool. Let's just draw a box around here to zoom in. You can use the scroll wheel as well. Zoom in on the micron bar here, and step one will be to make a line, and we can drag that line now across the scale bar here. To constrain to horizontal, right click and constrain to horizontal, and now the line will only slide left and right, not up or down, and move that on over to the end of the micron bar. So we've spanned the line. Step two is to type in the physical size of that line. It says 1 micron over here, so type in 1 micron, and now click calculate. And now, based on the physical size that we entered and the number of pixels, just about 305 of this line, that is the microns per pixel that corresponds to this image. When you click accept now, that number is in here. And if you were to save the recipe, in addition to the recipe steps being saved in and any measurements, you will also save this factor into the recipe. So as a demo, let me just save the recipe here, and let's say we clear it out. And if we load this recipe in, that factor will come with the steps. So Now, certain steps such as reject features can be made in units of microns instead of pixels, which can be valuable. And also, of course, your measurements now that we would make, let's again go back and do our equivalent diameter measurements. They will be reported automatically in units of microns instead of pixels. You don't necessarily have to have factors in the recipe. We could clear that out. We copy it first, clear it out, and now it says no calibration, which means that the image is not calibrated. Let me paste it back in. What you can also do is just save this number. Let's say this was a 500x image. So I might save it as cal 500x. And this was taken with the standard definition of my microscope. So standard definition. If your microscope has a high-res mode where it's shoving more pixels per image, then you'll obviously need a different magnification factor or a scale factor, since what affects the scale factor of an image is both the mag that it was taken with and the number of pixels that occupy that physical footprint of the image. If, for example, the image is now at half the resolution, which means the pixels are twice as big, then obviously your factor will be twice as big as it is in the high-res version. So we'd save that as cal 500x, and now we'd clear that out. Let's say we loaded this recipe in on a different image, and we didn't want to tie a factor to the recipe, but now we're ready to measure. We can just hit load and grab our cal file, and that factor comes in. So you can have a library of cal files for the different mags that you work on, and you'll only ever have to make those cal files once using the calibration tool. So that's all I wanted to show today, was the process for doing that. Again, this panel and this functionality is included in the batch, real-time, and processed image editor. So you can do that from whichever app you please. Thanks very much for watching, and we'll see you next time.